Hello, my dear students. So, today we are going to walk through May 2025 Unit 1 paper. So, without wasting any time, let's begin. So, let's solve the first question. It says which row shows the number of neutrons and electrons in bromide? So, bromine, if we go and check the periodic table, bromine is 35, right? So, bromine is 35, so bromide gains 1 electron, becomes 36. So we have two options, either B or D. Let's look at the number of neutrons. So I have 79 atomic mass minus 36, which is the atomic number. I'll get 44. So my answer is B. Do you get it? Next question. What volume of sulfur dioxide gas reacts completely with this much volume, this much concentration of sodium hydroxide? So if we see, the ratio is 1:2, right? I need to find the volume of sulfur dioxide. So let this be X, and volume and concentration is given. So I can easily find number of moles. So number of moles, C times V. And if you see, the volume is in centimeter cube, so you divide by 1000, you will get 0.05 times 0.12. 0.12, you get 0.006. Now, so let's find the value of X is equal to 0.006 divided by 2. So if we divide by 2, I get 0.003, and I have to find the volume. I have the moles. I will just multiply this with 24. So if I multiply this with 24, I'm getting 0.072. My answer is A. I hope this is clear. Let's move on to the next question. Yeah, it says which amount does not have the mass approximately 6 grams. So let's see, 0.33 moles. So you have the moles times the MR, you will get the mass. So now you have to see the mass should be equal to 6, right? So just multiply the moles into the with the MR, you will get the answer. So this is approximately 6, 0.25 times 24.3. This is also 6. Let's check the next one out. 0.33 times 180. This is also approximately 6. So I will get my answer D, 100% sure. This is coming to 3.99%, which is not exactly or not approximately 6 grams. So my answer is D. So you got the concept here, right? You have the moles, you have the MR or the AR. Just multiply, and you should see it should be not 6 or close to 6. So answer is D. Let's look at the fourth question. It says, how many molecules of water is present in 1 drop of water? Okay, 1 drop of water. Volume is given. Density is given. Density is equal to mass upon volume, right? And you have to find the mass. Mass is equal to density times volume. Density is 1, volume is 0.050, so mass is also 0.050. So you have the mass of water. You divide by the MR. So 0.050 divided by 18, you get 2.777. Okay. Now, multiply this with the Avogadro's constant, 6.02 into 10 to the power 23, you get 1.6. Answer is D. You multiply this with the 6.02, into 10 to the power 23. Clear? Next question. Which mass of fertilizer contain this much grams of nitrogen? So let's first see A. It contains, like in this formula there is only one nitrogen, right? So if I do the if I find the AR of this one, so it's 14 upon 85 into 2000 because it's 2 kg. If you solve this, 14 divided by 85 into 2000, the mass is 329.4. So this is not my answer. Let's check the next one. It says 1 kg of urea. In urea you have 2 nitrogens, right? So 28 upon the MR into 1000. And let's see, let's solve this. 28 upon 60 times 1000, you get 466.6. So question number 6 is asking for the correct order for the process in the mass spectroscopy. Well, this is quite easy. What happens first? The particle or the sample needs to get vaporized and then ionized. The ions get deflected and then on the screen they are detected. So my correct answer is B. Vaporization, ionization, deflection and detection. Clear? Let's see the next question now. So let's look at question number 7. It's asking which of these molecules are polar. So let's draw the structure. HCl, if you see, chlorine is more electronegative, so the shared pair of electron goes towards the chlorine. Okay, this is a polar molecule. And if we see BeCl2, this is not a polar molecule because the dipoles are in opposite directions. They cancel out. So this is not polar. And if we look at BeCl3, same thing is happening over here. BeCl3 is also a non-polar molecule. So my correct answer is A. HCl is the only polar molecule here out of these three. Okay, you should know that for any compound to be polar, it must have at least one polar covalent bond and a molecular shape that causes the bond dipoles to not cancel each other out. So there will be a net dipole movement. So I hope this is clear. Let's look at the next question. Which substance does not exist as giant lattice? Giant lattice, if you see, silver is having giant metallic structure. Sodium chloride also has a giant ionic lattice. Graphite is having a giant covalent lattice. This Buckminster fullerene is a simple molecule. If you don't know, you should know now that this carbon 60 is basically a simple molecule. It consists of carbon 60 molecules where you can see 60 carbon atoms are covalently bonded within each individual molecule, and there is weak intermolecular forces that exist between the molecules. So my correct answer is this. Let's move on to the next question. So question number 9 is asking which method for preparation of hydrogen has highest atoms economy by mass. So what you need to do is, you know the formula of atoms economy, right? What is it? It's the total molar mass of the desired products upon the total molar mass of all reactants into 100, right? So I have done for all the 4 and the correct answer is B. And how I did? So you just get the total molar mass of the desired product, which is hydrogen. So it's 6 upon water's MR is 18 plus CH4 MR is 16 times 100. So now if you just solve this, you will get 17.64 percentage, which is the highest out of the remaining three. So the correct answer is B. Question number 10 is saying which of the reaction has the atom's economy of 46.5 by mass. So you have to find the atom's economy for all the four options, and you have to see which one is 46.5 or close to 46.5. So the correct answer is C. How? You just find the MR of this, AR of this, and MR of this. You add them up together, you will get 403.3. And copper nitrate MR is 187.5 times 100. So you solve this, you will get the answer 46.49, which is 46.5. So correct answer is C. When you do the atoms economy for A is coming 59.4, B is coming 65.8, and D is coming 91.2. So the correct answer is C. So question number 11 is asking, what is the maximum volume of butane which will completely burn in 130 centimeter cube of oxygen? So we are comparing this and this. The ratio is 1:6.5, right? So maximum volume of butane is X in 130 centimeter. So 6.5x is equal to 130. X is equal to 130 by 6.5. You solve, you get 20 centimeter. Answer is 11C. So you have to find the empirical formula in this question. Let's begin. So let's find the mass of carbon from carbon dioxide and mass of water, hydrogen from water. So carbon is 5.15 times 12 upon 44. Hydrogen is 2.1 times 2 upon 18. Let's solve this. This comes around 140 grams. This will be 0.234. Yeah. So you got for carbon and hydrogen. Now oxygen is 3.50 minus 1.40 plus 0.234. You will be having oxygen 1.87 grams, right? Now what you need to do is you need to find the moles for C, H and O. So carbon is 1.40, 0.234 and 1.87. Carbon is 12, hydrogen is 1, oxygen is 16. You solve it, you get 0.117, 0.234 and 0.117. Divide them all by the smallest number, 0.117, 117, 0.117, 1, 2, 1. Ratio is 1:2:1. So answer is A, CH2O. I hope this is clear. For 1 mark, this is a crazy question. Which type of reaction occurs when alkane is cracked? Cracking, obviously, thermal decomposition. There is no other go. Thermal decomposition is breakdown of compounds by heat. And that's what's happening in cracking, right? You are heating. So, this question, it says, cause serious eye damage, harmful if swallowed, and is an oxidizing agent. So you know, the symbol of oxidizing agent is this, right? So you have two options. Either your answer is going to be A or D. But it says causes serious eye damage and harmful if swallowed. So answer is A. So this question is saying when hydrogen peroxide is used in the experiment to measure the rate of decomposition, how could the risk be reduced? Using an alternative method that involves less hazard, working on a small scale, or taking precautions. Now, if you see, I cannot use any alternative method because that would not work. So what we can do is we can work uh, on a small scale, and we can take precaution while doing the experiment. So answer is C. Question 15 is saying one molecule of hydrocarbon is cracked. You get two molecules of ethene C2H4 plus two molecules of propene C3H6 plus one molecule of propane C3H8. What is the molecular formula of the hydrocarbon? 3 carbon plus 6 carbon plus 4 carbon. 6 plus 4, 10 plus 3, 13. Answer is D, 15D. How many hydrogen atoms are there in this much grams of methane? So methane is CH4. I have 4 hydrogen in. Now let's see, the MR of methane is 12 plus 4 is 16 into 14 grams, right? So if I do this, I'll get 3.5. So how many hydrogen atoms? So 3.5 times the Avogadro constant. So if you times this, your answer will be C. Okay, which structure represents a pair of isomer? So basically you should know that isomer means same molecular formula but different structural formula, right? Let's see and check the molecular formula first. That's the first step. 1 2 3 4 5 6 carbon this side. 1 2 3 4 5 6 carbons. Okay, 1 2 3 4 5 and 6. 1 2 3 4 5 and 6. 1 2 3 4 5 1 2 3 4. So this is my answer, and if you want to make sure your answer is correct, draw the display formula and you will get your answer. So 17 is A. Okay, so which molecule has a geometric isomer? So for any molecule to exhibit geometric isomerism, each of the two atoms involved in the restricted rotation must have two different groups attached to it, right? So if you notice, if you see in this, A cannot be, because this molecule is having two methyl groups at one end of the carbon atom. Okay, carbon to carbon, you will see two methyl groups. B also cannot be the geometric isomer, because again it has two methyl groups at one end of the carbon to carbon double bond. If you look at C, this is also incorrect because this molecule has two methyl group at each end of the carbon to carbon double bond. So my correct answer is D. Okay. Now in this mechanism, the arrows play the major part. So you have to get the correct mechanism between the HBr and pent-1-ene to give the major product, right? If you look at A option, you will notice that the arrow is coming from the carbocation to the bromide. So this is wrong. If you look at the B one, B looks correct to me. Okay, let's look at C also. C again, arrow problem. It's incorrect because the arrows are going from the H plus towards the double bond. So this is wrong. Let's look at D. D is incorrect because Br is having a partial negative, which is wrong. So my correct answer is B. Okay. So mechanisms, you all need to memorize it. You all need to practice as much as you can. So this brings the end of part 1, and we will meet again in the second part of the video where I will solve the section B. So till then, enjoy.